Okay, this is chi-square test of independence, scenario 1, page 225 of your notes. So in a volunteer group of adults and older, volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. The program recruits among community college students, four-year college students, and non-students. The following table is a random sample of adult volunteers and the number of hours they work per week. And so I have this multiple rows, multiple columns. Are the numbers of hours volunteer independent of the type of volunteer? So there's a key word. So that right there tells me it's a chi-square test of independence. So and by the way, the other reason I know this is I have multiple rows and columns. If I have multiple rows and columns, that means I have multiple categories. So this is a chi-square test. They say independent. So I know it's chi-square test of independence. All right, so when I look at my recipe of success on page 224, the first thing that says is write my null hypothesis. And basically, what and what are independent? Well, what are my two things that I'm looking at? They want to know hours volunteer, independent of type of volunteer. Doesn't matter which one you put first. All right, so in this case, null, hold on just a moment. HO, our null. The number of hours and type of volunteer are independent. I'm going to make a little note off to myself, which is not associated, AO, and I'm just going to abbreviate because I'm out of room. All right, HA. The number of hours and type of volunteer are not. So we have are not and are independent. So here we're going to say the opposite of so if this is not associated, this is going to be they're associated. That's just a note to yourself. All right. So conditions. Fortunately, they told us it was a random sample. That was nice of them. Random sample given. I know I didn't include this in the goodness of fit, but I should have. N needs to be less than 10% of the population. So when we're talking about N being less than 10% of the population, my sample size is 839. 839 divided by 0.10 equals 8,390. That's a big number. Reasonable to assume that more than 8,390 volunteer. Therefore, N is less than 10%. And I'm abbreviating just because I don't have much room. Please don't do that on the test. All right, please don't do that on the test. Number 3. Expected values must be greater than 5. expected values greater than 5. See table. It's like, wait a second. We haven't done that yet, so we need to do it. So we need to calculate all of these. So it's essentially this times this divided by that. And I'll do that once, all right? So I'm going to go 298 times 255 divided by 839. And that gives me 90.572. And let's just say I want to do this one right here. Well, I can go 162 times 294 divided by 839. And I get 56.78. 56.768. That will take a long time. And you're going to have to do this anyway. So you need to learn how to do what I'm about to show you. So pay very careful attention. All right, because we're going to use some matrices, etc. And this will be very easy, but there's a lot of calculator steps. And I think you're going to end up liking this. So here we go. Second matrix, and I have not input my data yet. And I'm going to arrow over to edit. And I'm just going to press enter. And I look and I go, well, ignore the totals. We're not going to worry about the totals. If they didn't give them to you, you don't even have to mess with it. And I look at that and I go 1, 2, 3, 1, 2, 3. So I have 3 rows and 3 columns. So I need to make this a 3 by 3. 3, enter, 3, enter. And there, it should have adjusted it for you. 1, 1, 1 is my first enter. And I just entered the number, press enter. 96, enter. 48, press enter. The next one, 96, enter. 133, press enter. 61, press enter. 91, press enter. 150, press enter. And then 53, press enter. Once you've entered all of this, all right, second quit or second mode, just because we want to get to a clear screen. Now we're going to run the entire chi-square test, which I know seems a little bit crazy, but we're going to go ahead and do it. So stat, test, chi-square. Now this is not a chi-square goodness of fit test. This is the chi-square test. We're going to press enter, and it has A is observed, B is expected. And you're like, I haven't entered my expected. And I go, yeah, I know. You didn't. And we're going to write down some information right now because that way we don't have to come back here. And we end up having a chi-squared value of 12.9909. We also have degrees of freedom. They told us this value is 4. And I haven't showed you how to calculate that yet, but I will. And we end up with a p-value of 0.0113. All right. And those are just the values I got off the calculator. And you're like, yeah, but I still haven't done this expected value stuff. And so you're probably still going, okay, I'm going to have to go this times this, multiply and divide. And I'm like, no, you're not. So let's try this. Let's clear our screen and go second matrix. Arrow over to the word edit. And let's go look, arrow down to letter B and press enter. And look what we have, 90.572. Here we have 103. Here we have 104.42. Then we have 115.19, 131, 132.81, 49.237, 55.995. And you're like, hey, can I trust this? I said, well, let's try this out. 379 times 290 divided by this. Let's see if we get that. Second quit. 379 times 290 equals, divided by the 839, and sure enough, we end up getting 131. All right. So you can see real quickly that this is a pretty nice way to approach these problems. All right. So it did that work for us. So expected value is greater than 5, see table. Awesome. Number 4, observed is counted data. Counted / whole numbers. All right. So we've done that. We've done, so now we're going to go ahead, and the next thing we need to do is write our equation. And I'm changing colors to black just so that it doesn't show up, so it'll stand up against the red. So chi-squared equals observed minus expected squared over expected. And by the way, you never have to really name the test. You can just write the formula and you're good to go. So in this case, our first observed was 111. So 111 minus 90.572 squared over 90.572 plus plus my last one, my observed is 53 minus 56.768 over 56.768 squared equals, what did we say it equaled? Oh, we said it equaled 12.9909, so 12.99. Now, most of the time, they're not going to give you this table to fill out. And so you just come up there and go, you know what, since they didn't give me the table, I'm going to write 90.572. And usually there's plenty of room there. And then you go, okay, right here, this would have been 103. This is 104. And you just write the values there. And that's good enough. Write them and just draw a line and write them next to it. So the next thing, how did we get our degrees of freedom? Well, degrees of freedom for this test are rows minus 1 times columns minus 1. Well, it turns out we have a 3 by 3, so that's not very exciting. But 1, 2, 3 minus 1. So 3 minus 1 and 1, 2, 3, 3 columns. And 3 minus 1 is 2. 2 times 2 is 4. And you're like, well, the calculator did that to me automatically. Yes, it did. They will ask this question on a multiple choice when you won't be able to calculate it. They'll say, hey, we have this table, or we have this many rows and this many columns, et cetera. What's the degrees of freedom? So you need to make sure you know this formula, rows minus 1 times columns minus 1. So our degrees of freedom is in this case is 4. We know our p-value. Our p-value we already calculated. We had a p-value of 0.0113. And if you forgot it, just remember, I went stat, test, chi-squared, not a goodness of fit. And I'm pressed calculate, and there it is, 0.0113. And we ended up with an alpha. If we have an alpha of 0.05, this is less than. So we're going to reject the null. So that's our decision. And what did we reject? We rejected that they are independent. So that means we believe they are not independent. So in other words, we believe they're associated. So here's our conclusion. Our p-value is 0.0113. we reject the null. There is sufficient evidence at alpha equal 0.05 to suggest that the number of hours worked and the volunteer type are not independent. So, simplified, volunteer type and hours worked are associated. One other thing that comes up, every now and then, they will give you a chi-squared value. They won't give you a table, and they'll ask you, what's the p-value? So real quickly, just know that it's easy to do. Second vars, we just forget to exist. Second vars, chi-squared, CDF, CDF, our chi-squared value, 12.99. It's always going to go to positive infinity. And our degrees of freedom in this case was the 2 minus 1, I mean the 3 minus 1 times the 3 minus 1. So the degrees of freedom is 4.0113. So we actually got the same p-value. All right. You would have to know how many rows and columns, and you would happen to have the chi-squared value. But every now and then they'll say chi-squared, and they'll say it was whatever it was, and you have to know the rows minus 1 times the column minus 1, and then you'll be able to calculate it from there. Okay? All right, so this concludes this video. Thank you.